Okay, Miss Whitaker here, and we are going to go over the geometry review to prepare you for your test. So let's start with the first one. Number one, we have a protractor here. It says, as Joe was getting a toothpick, he accidentally dropped the box, and the toothpicks scattered on the counter. Joe noticed that 5 of the toothpicks landed on top of one another, as shown in the picture. So these are a picture of 5 toothpicks. We're going to use the protractor to measure the angles formed by 5 of these 5 toothpicks. So which of the following angles are complementary? All right, so this takes our knowledge of complementary and supplementary. Complementary, remember we make the S, and that lets us know that supplementary is 180 degrees, and then half of that is the C. So that stands for complementary, which is 2 angles that total 90 degrees. So the first thing I'm going to do is make sure I note that complementary means 2 angles that total 90 degrees. So I'm looking for 2 of these angles that, when they're added together, total 90 degrees. All right, so VTX is VTX, so it's this angle right here. And I'm going to measure this. It looks like I'm 2 before and 2 before here, so it looks like it's going to be a nice round number. I can do subtraction here. This is 108 minus 18, so that is a 90 degree angle, and it actually looks like a 90 degree angle, so I'm going to put that's 90. Now, I have a feeling that's not my answer because 2 angles that total 90, I can't have one of the angles total 90, so, but I'm just going to get my measurements just in case. So from X, T, Y, it looks like I've got 10, 20, 30, 33, 34, 35. So this is 125 total. That's not complementary. Next one, VTW. It looks like I've got 10, 20, 33, 34, 35. 35 for VTW. And XTY, XTY is going to be 10, 20, 30, 33, 34, 35. That together is going to be 70 degrees. That is not complementary as well. WTY, WTY here. This is going, looks like 53 and 143. And that's going to be about, let's just do that real quick. 143 minus 53. And that's going to be 90. That's also 90 degrees, and it kind of looks like a 90 degree angle. And again, this is not going to be complementary either, so I hope it's that last one. Let's do YTZ real quick. So YTZ is going to be, let's see, 10, that's 20, 22, and 20, 27. Well, let me just count that. That's 10, 20, I wonder if that should be that right there. So it looks like it's 29, right? So that's 29 degrees. That's 119. That's not complementary. So VTW's, this letter D, VTW and WTX better be the answer. So VTW, I think I've already said that was 35. And then WTX, I've already done that one. No, I haven't. So WTX is going to be 10, 20, 30, 40, 48, and 7. 48 and 7 is 55. 55 and 35 make 90. So that's my answer. So complementary, 2 angles that total 90 degrees. So I use the protractor. You can count the degrees in between, or you can use subtraction to find the difference. Just make sure that the answers make sense. All right, let's turn to number 2. The Morenos are camping and have just set up their tent. The front of their tent is shown in the relation to the ground. So here's the front of their tent, little pup tent, which names a pair of supplementary. So supplementary, I'm going to make a note. That's 2 angles that total 180 degrees. So I have ABE, which is ABE, which is this angle right here. Now, a couple of things I have to make note of. There's a whole bunch of different things I need to draw on my previous knowledge. First of all, if this is a right angle, then this is also a right angle. So this is 90. 90 and 30 is 120, and when I know that they all add up to 180, this one's going to be 60. So then this one over here, because it's a supplementary angle, I know that this right here is going to be 120, because this together makes a straight angle, or 180 degrees. So ABE is 120, and then ADC I know is ADC, it's this angle right here, so it should be, this is 90, 30, this should be 60. So 120 and 60 do total 180, and I think that's my answer, but I'm just going to check the others just to be sure. This is 120 again. ADF is going to be 120, so that's 240, that's not it. ACD is 90 degrees, and ADC is 60. That's 150. That's not going to be it. ADC is 60 degrees, and CAD is 30. That totals 90, so that's complementary, and that's not our answer. So I know that A is my answer. All right, number 3. A pole fell from its vertical position and is now leaning against the building. Here's the pole. What's the measure in degrees of the complement of the 51.4 degree angle formed? So we're looking for the complement. Complement means the other angle, so they total 90 degrees. So I just take 90 and subtract 51.4. I'm going to have to line up my decimals. I'm going to have to borrow. So 38.6, and I'm just going to double check. 38.6, and if I were bubbling that in, it says have a bubble grid. We don't have a bubble grid. So 38.6 will be fine. All right, number 4, it says in the diagram, line M is parallel to line N, so that's information we need to know. It says which two angles listed below are supplementary. They total 180. Just going to keep that in mind. All right, angles 5 and 6 form a right angle, so that totals 90. That doesn't total 180. 1 and 2, that does make a nice straight angle. Those are supplementary, but I'm going to keep trying just to make sure. 8 and 9 are right angles, so that's not it. And 7 and 8. 7 and 8 are going to not be, it's not going to make a straight angle. It's 90 degrees plus a little bit here, so that's not going to be it. I know that. Does not equal 180. All right, let's move on to number 5. Study the diagram of the triangle inscribed inside the square. So here's my triangle inside the square. Which of the following two angles are complementary? Complementary totals 90 degrees. 2 and 3, that does not look like a right angle. 8 and 9, that does make a right angle, but I'm not going to stop right there. I'm going to check these others just to be sure. 5 and 9, 5 is already a right angle, so this is not going to, when I add the 9, it's not going to be complementary. And 1 is already 90 degrees, so combined with the 7 is not going to work as well. All right, so I have my right answer. All right, and then number 6 right here. Haley took a 12-foot pole and laid it across a swimming pool as shown. Here's our pole across the pool. So it says, what is the measure in degrees of angle 1, assuming the pool is rectangular in shape? Well, we're told the angle that goes with, that's supplementary to angle 1 is 48.7. So if I see that they both total 180, I can just do 180 minus 48.7 and line up my decimals there. And that will be 131.3. I'm just going to double check by adding those back up together, so they total 180. That's going to add that. That's 180. So 131.3 0.3 degrees. It makes sense. That looks like an obtuse angle, so that makes sense. All right. Turn to the last page. Myra's teacher, Miss Ortiz, is describing a shape. She tells her students that the shape is quadrilateral. That's 4 sides with 2 pairs of parallel sides. I know that's a parallelogram. She also tells them that all the sides of the shape are equal or congruent. All right, so that's a rectangle or a square. No, it's just not a rectangle. That would be a square or a rhombus. That none of the angles measure 90 degrees, so it's not a square. So which shape is she describing? It'd have to be a rhombus because these have angles that are 90 degrees. A rectangle does too, and not all the sides are congruent. And a trapezoid only has 1 pair of parallel sides. So I know my answer is correct because I've looked at all the other answer choices. Make sure you're familiar with the definitions of all of these quads. And number 2, a quadrilateral with all 4 sides congruent would be rectangle? No, I don't have to have all equal sides in a rectangle. Parallelogram? No, I don't have to have all equal sides. Trapezoid? No. No, it's not a trapezoid because I don't have to have all 4 sides congruent on this one. And rhombus is, by definition, a quadrilateral with all 4 sides congruent. All right, let's go to number 3. Which of the following statements is true? So we're looking for the true statement here. A triangle with an obtuse angle is a right triangle. No, that's not true because that would be an obtuse triangle, so that's not true. Each angle of a rhombus measures 90 degrees. No, I could have a tilted square, and those do not have 90-degree angles. So remember, as I said, be thinking of non-examples. As soon as you're looking for a true-false statement, look for any example that you can that proves this false, and then you know it's false. Let us see. A trapezoid has 2 sides that are always perpendicular to each other. Well, do we know what perpendicular means? Perpendicular means that they intersect and looks in the shape of a T. So that's not true. That's not how we define a trapezoid. So I hope that this one's true. A triangle with a 90-degree angle is a right triangle. Yes. That's a 90-degree. If it has a right angle in the triangle, then it's called a right triangle. So I know my answer is D. And number 4, Dewana notices a manufacturer's symbol at the back of a bag of chips. The symbol's not shaped like a quad. It has 3 sides, so I know it's a triangle, none of which are congruent, so that tells me it's scalene. The symbol Dewana sees is in the shape of a scalene triangle. It's not a triangular pyramid because it has 3 sides. A pyramid is actually 3-dimensional. An isosceles triangle has 2 equal sides. A scalene has no equal sides, which was in our example here, and the trapezoid is a quad. So look at all your answer choices. All right, number 5. Which statement is true about all parallelograms? Opposite angles are equal. Is that true about all parallelograms? Well, possibly. Let's look at the others just to be sure. The diagonals are congruent. Well, I don't know about that. Let's see if we can draw an example. Do you think that this is equal to that? I don't think it is. This one looks like it's closer. These are farther apart, so that's not it. There are 4 right angles. Well, I just drew one up here that doesn't have 4 right angles. There are 4 congruent sides. Well, once again, I drew a parallelogram that does not have 4 equal sides, so I'm pretty sure that A is right. Opposite angles are congruent, and what that means is that this angle matches this angle, and this angle will be the same as this angle. So those match. All right, number 6. Which figure could contain exactly 2 obtuse angles? Now, we talked about this with triangles. Could you have 2 obtuse angles in a triangle? Well, I mean, I can try to draw an obtuse triangle, but that's just one obtuse angle. I don't think I could do another one. So it couldn't be a triangle. A square couldn't have two obtuse angles because they have to be right angles. Rectangles also have to be all right angles. So I'm thinking that we do not have an answer choice that satisfies that. All right, and then briefly, just make sure as you prepare for the test, go over the vocab that we talked about. An acute angle is less than 90 degrees. A right angle is equal to 90 degrees. Obtuse means greater than 90 degrees. A straight angle is equal to 180. All right, then complementary angles. Two angles that total 90 degrees. Supplementary angles are two angles that total 180 degrees. Then we get into triangles. Make sure you know all the different kinds of triangles. Remember, we classify according to the sides and also by the angles. So this is according to the angles. I can have an acute, has all angles are acute. A right has one right angle. Can't have two right angles in it. And obtuse has one obtuse angle in it. All right, then we get down to classifying triangles according to their sides. A scalene, no equal sides or no congruent sides. Isosceles has two equal sides, and it will look, they'll have the little marks that mark those two equal sides. Equilateral, all sides are equal. And remember that all the angles are going to be 60 degrees because they're all equal, and it has to total 180. So 180 degrees is the sum of the angles in a triangle. No matter what that triangle looks like, it's always going to total 180. All right, quadrilaterals are your four-sided figures. Trapezoid has one pair of parallel sides. It could look like this. And those two parallel sides are called bases. And then these are the legs. It can also look something like this. I can have a right angle there, but I only have one pair of parallel sides. These aren't parallel. So just keep in mind what the definition is. A rhombus, four congruent or equal sides. That's all I need, four equal sides to be a rhombus. And usually you think of a tilted square. All right, a parallelogram has two pairs of parallel sides. And it's a quadrilateral with two pairs of parallel sides, and it could be a square, it could be a rectangle, it could be a rhombus as well. All right, here we've got a square has four congruent sides, just like a rhombus. But then it goes farther and says all 90-degree angles. Okay, so we have all right angles and all sides are equal. In a rectangle, we've got, it is a parallelogram. So it has two pairs of parallel sides with all 90-degree right angles. Congruent, just make sure we know equal or same. Parallel, two lines that will never intersect. A polygon, poly means many, Gon means sides, so many sides. It, by definition, is going to be 3 or more sides. So it starts with the triangles. We've got triangles, and we've got quads. That's the 4 sides. 5 sides is pentagon. 6 sides is hexagon. 7 sides is heptagon. 8 sides is octagon. 9 sides is nonagon. And then we have a decagon for 10-sided figure. So polygon just means many sides, and by definition is 3 or more sides, and we could just keep going. But just make sure you know these basics right here, especially triangles, quads, pentagon, hexagon, octagon. Make sure you know those basics. So make sure you're prepared with the vocab. Make sure you know everything that we went over the review, and come prepared to your test tomorrow. Good luck.